Welcome back, everyone. And today I'm going to do another challenge. Some people enjoy watching me kind of create these wacky animations based on what other people have done. So recently, Bees and Bombs posted this animate GIF file. And if you don't know this Twitter account, this guy kind of creates these mathematical animated GIFs, and that's all he does. He doesn't give you source code, doesn't give you anything. They're not necessarily challenges; they're just things I guess he does for fun. And I saw this, and I thought this was kind of really cool effect. And after a while, I started noticing that these are actually rotating cubes. So I thought, you know what? If these are rotating cubes, I can probably create this in a WebGL. So I put it upon myself to challenge myself. Can I recreate this myself? One thing is I did notice is that this is also isometric view. Isometrics is a type of view. Sometimes you see certain games. Diablo is an isometric game, I believe. So things like that. So, and that requires you to create an orthographic projection. So those are things we haven't done before. So I thought, you know what, if I can get this working just right, it'd be a great example for isometric view and orthographic projection, and some fun animations while we're at it. So as you can see, here is my example. I managed to actually put it together. But see, it, there you go. And I can rotate it to prove that it's WebGL. So one of the first order of business when we were dealing with this is like I noticed it had this texture. So I was gonna all right, I'm gonna have to make an image for this. So I just before I decided, I was like, you know what, that's such a simple texture. I wonder if there's an easy way to do it in with a shader, and of course Google provides. And I found this one article, I guess by number 23. And he kind of goes and describes how to build a cube, or not a cube, a diamond in with shader code. And he goes through it. You should really check it out to get an understanding. I don't use all of his code. I don't use fwidth, but I did use one of the other kind of examples of how to put it together. And there's only one issue I found personally, is that this line of code, one doesn't work for me. I don't know why it doesn't work for me. I don't know if it's because I don't know what its coordinate in his center is that he's using for this. For me, I need to use a 2. A 2 works perfectly. I can recreate this this example. So that's the only thing. If you're going through here and for some reason it doesn't work for you, increase the numbers a little bit. It might be just for some reason what you're using needs a different value. But overall, like I said, this works out really well. I'll put a link in the description so you can read it. He has like more than one example. Like I said, I didn't use fwidth, so I was able to get away with it. And yeah, so once you got that shader, we need a couple of fungi changes. Oops. So we got our diamond shader, which I'll show you in a minute. And the only real big change is to our orbit camera. In our orbit camera, I created a new function called Ortho Projection. And it has already some defaults already set up. That's all good and good. And all it does is it creates a new projection matrix to use for our camera. I forget what projection matrix we use. We use a different projection matrix. Perspective. We use a perspective for all our WebGL stuff. So this is kind of the first time we're actually going to use Ortho Projection. So this is kind of neat. Like I said, it allows you to kind of create isometric views. And isometric and Ortho Projection gets rid of a lot of the depth view. So there's a little depth in it. Let's see. Let me go back here. So you kind of lose that depth. It doesn't like skew your 3D model to give it like this nice depth look. So everything's kind of even, no matter which angle you're kind of in. So that's what Ortho Projection kind of does. And the only thing it kind of also does, it kind of negates Z. I can't move on the Z axis with the camera because of Ortho Projection. Like it's negated. Like it's not used. It's used more as a way to overlap things. Ortho Projection mostly is used for UI. So the UI so you can just set the kind of overlapping order or like the layer order based on Z. So everything kind of stays the same size, no matter what the Z position is, kind of. So there's no way to zoom in and out. The only way to zoom in and out is to kind of change the scale in which Ortho Projection works. I'll probably show you that in a bit. So let's look at the shader. Shader code is pretty simple. We only got one uniform, and I want to set invert. And it's just the value 0, 1, and we're going to have two materials. We're going to have the diamond and the diamond inverted. So this way we have two styles. Just like in this original example, you had a diamond that's black and you have a diamond that's white. So you had two different colors. Our vertex shader is very plain. It's as bare bones as you can get. And then all the magic happens in our vertex shader. So we have our inverted color, which, let's see, how do I use it? You can ignore all this. To make life easier, I'll switch it to C++. There you go. So things get color-coded a little bit. Let's see. Where do I use uinvert? There it is. So instead of creating like an if statement to say, okay, is it turned on and off, or like making an int or something, I decided to make you invert an actual value. So in the math equation, if I want to invert, I just say 1. It'd be 1 minus whatever the step smooth step is. And if I don't want to invert it at all, I just set it to 0. So when it does, it makes a negative, but then I use absolute. So basically, I'm using the absolute function in place of an if statement. So that's the only change I've done to the shader code. I don't know what's better, to have an if statement or use abs and then use it. There's a little trickery, but that's what I did. And like I said, this basically ends up doing the calculation. This one does the smooth step so it's not so I don't know. I think this one's actually what makes the solid color. Like this one creates that gradient. This one makes it nice and solid, and then it's just grayscaled. Like I said, simple. And inside the shader, I saved the link to the original article that actually helped us make this. So credits where credit is due. So now we got our HTML page, and we have our new shader, and we're going to create a cube, and we put our thing into it. So with that in mind, this out of the way, this is what we have. This is what we start with. This is like basically what I end up starting with. Okay, now I got a cube. I finally got the diamond shapes. Now I need to animate it. So I just sat here and just really watch what what the cubes are doing. It's definitely rotating, and if you notice, it's actually rotating per axis. So that rotated Y, that's X, that's Z. And if every other one is actually rotating on the exact same axis, but each one is inverted. One's going left, one's going right. So that's the pattern. So it's easy to see the pattern of rotation. The other thing you notice, it's zooming out. So I thought it was a zoom, but then I kind of was like, wait, since I can't zoom in Ortho Projection, I'm actually scaling. So your first order of business, you got to scale, you rotate, and then you scale back. So once you sit there and analyze the animation, then you do exactly that. So down here, I have a function called animate cubes. It should be just animate cube, because this function only animates one cube. So let's see. The first order of business. Another thing that you have to realize, there's kind of this pause between rotation animations. So I created like an animation delay, an animation start. So I have about 1 second worth of time. So I wait for 1 second basically. So if animation delay is greater than start, then I can start animating. If it is not greater than start, I just keep adding delta time to it. So delta time is just a fraction of seconds, how much time the previous frame took to render. So once that delay is greater than the start, then I get to get started. Let's see, T. Animation speed, T. So now I kind of want to move throughout time. So animation speed. So I want to move a certain amount of how I want to go at a certain speed. So I want to go at 1.1 per second. So 1 per second with dt is a fraction of a second plus t. So I'm just kind of adding to t, and this frame. So this frame t is 0. So I'm actually starting my animation. So 0 plus that, and I don't want to go greater than 1. So I cap it at 1. So I can't go any higher than 1 because t I want to keep it at 1, because the next thing that's happening is I have something called animation state. This is kind of like a very simple basic state machine that I put together to change animations as time progresses. So like I said, the first thing I need to do, I need to scale down. So that's state 0. So that's why I also keep the state that I'm right here, animation state. So I'm currently at an animation state of 0. So I'm going to do the scale down animation. When I'm done scaling, I'm going to do a rotation animation. So I end up moving to state 1. And when I'm done animating the rotation, like when t equals 1, that's why I kind of cap it at 1. So I know when certain animations are done, I move to a different rotation, because I actually have two states. I have animation state, and then I kind of have an axis state, because you remember in the original example, he rotates on x, y, and then z, or y, x, then z. And I actually save the animation or the axis of rotation in a list. So I basically kind of just loop through this nonstop. So every time I'm done doing this animation, I move it forward. And once it reaches a z, and then I'm back to the loop, it kind of loops it right back to 0. So that's what this little math thing does. It just keeps it moving forward, but keeps it between 0 and 2. So this way, as time progresses and I'm moving from state to state, I get that animation going. So I get that change of axis rotation very easily. And I set the angle of rotation, and I use easing, because there's kind of that easing effect. It's like it kind of spins kind of quickly, and it kind of slows down at the very end. So easing cubic out seems to do it just right, and then I do it at half pi. That's 90 degrees. And then when you're done rotating, you scale right back up. And again, you use easing. So so you take the time of easing and then some numbers. Like I said, I just played around with it until I got exactly the scale I needed to be to kind of look like what I forgot what is his name, Bees and Bombs. What Bees and Bomb does, and it's kind of inverted because there's 4 here minus 1, and then +4 +6. That's the only difference you got. You have to realize is that in the end they kind of have to. If I'm doing 1 - 4, that means I'm going to end with at 0.6. So I have 0.6 and I need to add 4. So I need to get back to 1. So they're kind of like inverted. I'm trying to get back to 1, and here I'm trying to get to 0.6. So this controls all the animations. Now, like I said, here's another reason why I said I want to cap at t. At the end of an animation, once t hits 1, and I do the final whichever animation I'm doing, and that's another reason why t is important. I need to reach the end of each animation. If it's greater than or equal to 2, I'm going to reset t, and I'm going to move the animation state forward. And if the animation state moves beyond the maximum, I reset everything. Everything goes back to the very beginning. And one complete cycle of animation state is when I go through here. So if I go 0, 1, 2, and the next state is 3, I go right back to 0 and redo this, and I do the next axis. So for first time through, I do the animation for X. The next time through, I come with Y. Next one is Z, and just keeps going on and on. And this is the function, and this is what creates all those functions, all that animation. So if I say animate that one cube, refresh, scales down, rotates, scales up. Scales down, rotates at a different angle, scales up. And then Z. There you go. And that's it. So once you got the textures, you got a nice texture going, you got the cube, and you got the animations, you're pretty much all the way, you're done. You're almost done. The only thing left is now to switch projections and just throw a bunch of cubes in and just do them have every single one inverted. So to do that, I decide to make a function, or not a function, a class that actually manages all that work for me. So I say cube, and I make a new class called Fancy Cubes. And I just call Fancy Cubes update with the delta time. So all this is kind of worthless. And as you see, a lot of things here I kind of end up repeating here. And I just create an array of cubes. And when we initialize this function, I create all the cubes. And here I create a list of every position I want the cubes to be in. So these are just the positions that the cubes exist in. And let's see. And as I go through, I set the diamond, I set the position, and I set the material. I think the fourth component determines in this, because this, how many, is it 4 components in here? Yeah, there's 4 components. The first 3 are the XYZ position, and the fourth component is which material to use. So if it's 0, I want to use that one, else I want to use the inverted one. So so that controls it. So this controls the order in which, the order also is important because I use the order as a way to determine which direction to go in. And some cubes go left, some cubes go right. So I have like a function called isEven. So if it's the even, I know which way to go. So during update, it's the same thing. You know, we have the same if statement for animations. We still have t. We still have our animation states. And I use a little bit of functional programming to do the rotations for all the cubes. And the only difference is I use isEven. If it's even, I multiply by 1. If it's not even, I multiply by -1, which basically inverts the value. So that's why I said I put this in the right order. I put all the cubes in the right order so the evens go one way and the odds go the other way. So this way you got that that effect that he does. Like this one goes one direction, but this one goes a different direction. But the top and the bottom go in the same direction, while the middle's different. So I just sat there and just kind of moved each cube in the right position so that they all kind of are ordered correctly. And originally I had 8 cubes, and I got rid of one because it got in the way. And apparently once I took that one cube out that you can't really see, it's hidden by everything else, all the animations work exactly. So I have a feeling that Bees and Bombs probably did a very similar way, because if it's 7 cubes and then if you do even and odds, it somehow magically worked beautifully. So I think he might actually did it this way. It would be great if he can confirm if this is how he did it, because it'd be kind of funny if you have 2 people that kind of stumble on the same thing. But yeah, like I said, everything else kind of stays the same. I probably clean things up. Since I'm using arrays of cubes, I'm just using functional programming to animate all the cubes in one go in one line of code instead of writing a for loop and everything else. Like I said, everything else stays the same. So if I go here, I got this one cube. Next thing up, now I got there's that one cube that's missing, but everything's good. And this is it still works pretty. It looks pretty good as a perspective projection, but it's not exactly like how he has it, because everything is nice and even, But that's because he's using isometric view. But even this is still pretty good. If you angle it just right, it still looks kind of cool. But let's say the whole point of the challenge is try to get it as close as possible to what he has. And the last ingredient is orthographic projection. And here you go, orthographic projection, 8. 8 is a scale. Let me see. Let me go to the cameras. I probably should have this open. Now, I had a little difficulties dealing with ortho projections because I went to read up on it. And a lot of tutorials say use the width and height of the canvas. That doesn't work. I don't know if it's because of the ortho or whatnot, but for some reason it works but does not work. It's kind of like everything is like zoomed away really far. But then I saw another guy who I can't remember what he was doing, but he did ortho projection and he had all the sides equal, and he made the values all 1 or -1. So I tried that, and that kind of worked. That kind of worked for me. Now, the only problem is, maybe I should show it so you guys can kind of get an idea. Let me actually turn it on first. So there you go. I refresh. There's ortho projection or working beautifully. That's it. The end. That's the end of the video. But let me just walk you through ortho projection to kind of explain to you how to get it working right. In case the way other people tell you to do it doesn't necessarily work for you. It's always good to have another reason why. Like I said, I might be doing something wrong and I need to fix it. Or just because I'm using WebGL and using a different type of matrices or whatever, maybe it needs to work differently. I don't know. All I know is that I got it to work. So I use 8 as a zoom value. Ideally, like I said, with ISO projection or ortho projection, Z doesn't work. So this is like the Z value. So if I do that, I get closer. So if I want to zoom out, I need to I have to change the ortho projection to zoom in and out, basically in a Z-axis type of way. So, but that's how the function is built. That's how it seems to work for me. It might be because maybe my orbit camera does some funky tricks to rotate. Like it doesn't use look at rotation. I actually do like a little bit of trickery to get the orbit camera to work. I moved on the z-axis and then I rotate the camera, as opposed to rotating the camera and then translating, which I think is the normal order of operations. I changed the order of operations to make it very easy to do it, so I don't need the lookup of rotation. So I don't know if that's part of the problem why it does. Other people have it working, and for me it doesn't work. But like I said, I don't know why. It could be me. Maybe I'm just understanding other people. Maybe they don't work and I got it working right. I don't know. I really don't know. All I know is how I can get it to work. So if I make it everything equal 1, because this became a clue to me. And what? Save. There you go. It's not zoomed out very well, but when I had one cube working, I was like, the one thing you'll notice that it's stretched. It's like, wait a minute, it's stretched out. I was like, oh, okay. It's like at this point, it's like, okay, it's. I'm getting closer to Iso Projection, but now you're noticing the cubes are stretched, and it probably helps with one cube, but take into account how it's stretched. Like I want to try to kind of walk you through the troubleshooting. It's stretched out in the same dimension as the viewport, so it's stretched out at the viewport. So that itself is a clue. It's like, okay, it's stretched. I put everything as 1, and if you remember how viewports work, that's -1. That's 1. Up here is 1. And down here is -1. So if the actual viewport coordinates are within that range, I think it's I forget it's called, NDC coordinates. I forget. There's so many levels of coordinates when you're dealing with WebGL. I think normalized something. I think it is NDC coordinates. So that means it's corresponding to the size of the viewport. So now that I know, okay, I need to set up something that's related to the viewport. So, but the width and height doesn't work. Let me undo. Let me show you how what originally looked like when I actually followed other people's tutorials and how alternate projection works. This is the original view. This is why I said it doesn't work very well. Refresh. The whole world is tiny. It's like zoomed in far away. But everything looks like it might be even, but it's like super far away. So using the actual size of the viewport makes it too far away. Using the values of 1 makes it stretch in relation to the viewport. So with those two things in mind, it's like, well, then for me to do this, I need everything to be done in a ratio based on the viewport. So I say width is 1 times zoom, because like I said, I need this. So it's a ratio. I need to create a ratio value, and if I want to control the zoom, I need to zoom in by that ratio value. So I kind of need to create a very simple number. So I just said, well, width equals 1. So width is 1 times zoom. Then I say whatever height it is divided by the width of our viewport. So I'm creating a ratio of our viewport times zoom, and that becomes height. So like I said, if width is 1, that means this technically is supposed to be 1. Using that as a division for height, basically say in relationship of width, what's the ratio relationship of height to width? So if width is supposed to be 1, how is height divided into width? So if height is smaller, it'll give me a value less than 1. if it's greater than width, it's going to give me a value greater than the value of 1. So if height is greater, it's going to give me like 1 point something. And if it's less, then it's going to be 0 point something. So width is always going to be 1, and height is going to be less than 1. If the viewport is where the width is greater than the height. So like I said, this creates a value of 1, and this one creates a value less than 1 because my viewport has a width greater than that's greater than height. So like at that point, zoom becomes a scalar, and you just multiply it, and then you use that value, and you got perfect ortho projection. So like I said, I read several tutorials, and no one explained how it really worked. So maybe that's really how it works. I just had to troubleshoot to the point that now I kind of understand, or at least I understand how that ortho projection equation I'm using from GL matrices to get this to work right. So so the width of the canvas the size of the canvas does not work. You need to, I guess, normalize it in a way. You need to create a ratio. And when you use perspective perspective projection, you kind of have to create you have to add a ratio anyway. So it makes sense that ortho also needs a ratio. But like I said, I had to troubleshoot it and solve it on my own. So, like I said, in case you have ever problems with ortho projection, play around with it, and you might notice little things here and there as you progress. Just pay attention to how everything displays itself. And another thing I think I had to make it work right is I had to set near to -10. Normally we have near 0.1, and if you do this, it cuts it. It cuts it where x is 0. So that red line is kind of like that origin point, and everything gets cut at that line. So we're in a projection, perspective projection. We do 0.1 to 100 to get the cutoff point. Orthographics, you need to go like basically behind the camera in kind of a negative direction. So this way it doesn't cut your scene. Sometimes you might need to go even higher. Let's see, 20, depending on how you're doing your views. Like 20 works. 10 works for me too. But I think if I move it a certain way, I guess for me it works pretty well. I think, like I said, I kept messing around and trying. And that's it. That's really ortho projection. And the only thing that really makes it an ISO view is the angle in which you view it. I think I was reading an article, and it says everything had to be like 30-degree angles to make everything perfect, isometric. Like the Y has to be a 45-degree angle. So you got that 45-degree angle. I think it says it was 30, an article mentioned. That didn't work very well for me. It was kind of skewed. If I do 30. Like it's not perfect for some, like I don't see it as perfect. To me it didn't mirror his view perfectly. Like I can't there's like something, like if you sit and just stare at it, you're like there's things that are a little off. So I start messing around with some of the values, and 35 creates it perfectly. I think it was like looking at this triangle right here. Yeah, so that top, you see that triangle? Like, I needed that to be, everything needed to be even. So yeah, like the top, when it's not done being zoomed, in the way it animates. So once I start messing around with it a little bit, I got it perfect. So for me, to get ISO projection, I need a rotation. The camera needs to be rotated at Y 45 degrees and on the X -35. So this gives me the perfect ISO view. So if I wanted to make like an ISO game, this is it. I can then just walk around. You just move the camera. You can make Sim City, and you can rotate it. I think once you start rotating, you're not really no longer an ISO projection. ISO projection seems to be kind of like the static view, I think, that you're kind of stuck there, and then you may have something that does a rotate, so you can look at different angles. But yeah, that's it. But there you go. But you can, like I said, this is still attached to the camera, and oh, this is cool. That looks pretty neat. Let me I forget. I think if I say 0, there you go. I get rid of so let me see if I can rotate it behind it, because I think it gives a different look. I just gotta get the right angle just right. There you go. How's that? Something different. So here, this is the front, and this is the back. This is the butt. This is the butt side of that animation. So you know what the butt side looks like. And there you go. And that is the end of the challenge. Bees and bombs. Thank you for posting this image. It's really cool. I really loved trying figuring out how it works. You have tons of stuff in here. You have tons of stuff that I just can't even imagine how to do it. But thank you for this one, because, like I said, I managed to learn a lot. I learned isometric view and how to use Ortho Projection, which is something I just hadn't found a reason to use it yet, and this finally gave me a chance to really play with it. And like I said, this is pretty neat. Like I said, I managed to learn quite a lot in doing this, and hopefully you guys learn too. So yeah, so I guess I end the video just like this. There you go, challenge complete. So our next video will be about going back to textures, generating textures. So if you guys see any other challenge from Bees and Bomb or David Smith or anyone else really that you think might be really cool, pass them along. If it's within my realm of understanding, I will give it a shot. So, and create a video on how to go about doing it, or my interpretation of how to go about doing it, as close as I possibly can. And today, I think I was actually quite successful. I managed to replicate it perfectly. So I'm very, very happy with this one. This one turned out really, really well. It just means I'm growing as a graphics developer, a graphics programmer. So, and hopefully you guys are joining me on this ride and learning and being just as good, if hopefully better than me, because that's what all teachers hope for, students to be better than them and teach them a few things. So that's it. The usual YouTube BS, like and subscribe, and see you guys at the next video.